Hello, chemistry class. Mr. Debski's here, and I was just telling my period 6 class I felt bad for period 1 because I think I scared you to death. So in honor of period 1 and period 2 a little bit less so, and for anybody who wants to watch this video so that you can do well on this test, Hess's Law. Yay. Okay, this is the definition of Hess's Law. Really what it comes down to is if I add two things together, they are going to equal what they add up to. How about that? And I used an illustration in second period, which is much better than first periods, about algebra. If I have something that looks like this, and I have something that looks like this, and I'm just making this up, but okay, so I got two equations and two unknowns, and you all learned in Algebra 1 there's 3 ways to solve that. Number 1, you can graph them. They'll have 2 straight lines, and where they intersect, ta-da, that's your solution. Number 2, you can solve one of them for x or y and substitute. Remember substitution method. Substitute into the other equation, thereby making one of the variables disappear. Or 3, the third method, would be to, I forget what it's called, elimination. But basically we're gonna use a couple tools. We're gonna rearrange these so that one of the variables cancels out. And really in algebra there's only 2 things I can do, and you're going to see the parallel to Hess's Law in a minute here. So the first thing I want to do is I want to rewrite this second equation so that I have x and y and a constant over here. So I'm going to say this is the same as 4x plus 2y equals 1. Okay, and we can get rid of this. This is the same thing as that. And then when I look at this, I have several options available to me. I can multiply this one times -4 and get -4x, so that cancels out with this. Or I can multiply this one times -1/4. No, don't deal with fractions if you don't have to. Then I could also do the hard one. Multiply this times -3 and multiply this times 2 and make the y's go away. Or multiply this times -2 and multiply this times 3 and make the y's go away. But it sounds like the easiest way is what? Multiply the first one times -4. And so when we in algebra, when we multiply this by -4, we get -4x, we get -12y, we get -24, and then I just combine terms. These cancel out, -12 plus 10, -10y, and -23. Get rid of the negative signs, y equals 23/10 or 2.3 if you want. Now, what I like about Hess's Law is it's kind of like that. We're trying to get to an answer by combining 2 and sometimes 3 other chemical reactions. The only thing I can do to those chemical reactions, and I'll show you the 3 rules in just a minute, is either do what I did first, swap things around. Secondly, multiply by a constant, or multiply by a constant and swap things around. So Hess's Law goes like this, okay? Don't look there. That's what scared me. So here's the rules of engagement for Hess's Law. And I want you to write these down, and I want you to memorize them, okay? Hess's Law says we are manipulating equations so that they add up to what we're trying to figure out. So there are only 3 things we can possibly do. And these are the 3 things you need to remember. Number 1, we can reverse the entire equation. In other words, I can switch. So I'm going to get rid of my algebra expression now, okay? I can switch my reactants and products around, and all it's going to do is change the negative to a positive on my delta H, or the positive to a negative. So if I had something that looks like this, hydrogen plus oxygen produces H2O. Okay, very common reaction. We balance it here with a 2 and a 2. And if I said this was -600 joules or kilojoules or whatever, I can rewrite that if I need to, like this. 2 H2Os. Instead of synthesis, it becomes decomposition, and I just swap the reactants and the products. I can do that. And what is it going to do? This number, it's going to change the sign. So what was exothermic now becomes endothermic. Why is this true? because when I do this, I'm breaking the hydrogen and oxygen bonds and forming the H2O bonds. And when I do this, I'm breaking the H2O bonds and forming the hydrogen and oxygen bonds. It's the same number of bonds being broken and formed in both cases, just in the opposite direction. So the amount of energy or heat that's either generated or used is exactly the opposite. Number two, just like we did in the algebra expression, we can multiply the whole reaction by a common factor. That factor can be a whole number or it can be a fraction. So I've given you a couple examples here, 3, 2, or 1/2. So again, if I had this reaction here, and suppose I needed 4 waters on the left to cancel out with something else on another reaction, I can now multiply this whole reaction by 2, or 3, or 6, or 1/2 if I need to. 2 times 2 is going to be 4 H2Os. 2 times 2 is going to be 4 H2s. 2 times 1 is going to be 2 O2s. And I have to do this as well. 2 times 600 is 1200, okay? And it's still going to be endothermic. So rule number 2 says I can do this. Remember, this is the same as this, although it's not the simplest form. This is going to be true. It's still balanced. And it just doubles the amount of energy. And step number 3, you don't really need to memorize. It just says I can do both of these at the same time. Okay, I can swap something around and multiply it by 2 at the same time if needed. So I'm going to demonstrate that. We got time to do at least 2 problems. When you manipulate an equation, you must manipulate the delta H, the enthalpy change, in the exact same way. So again, if I multiply by a constant, I have to multiply the delta H by the constant. If I divide everything by 4, I would need to divide my delta H by 4. If I reverse it, flop it around, I need to multiply, change the sign on my delta H. That's all we can use. Okay? So let's do a problem. The best way to learn these is to solve the problem. So I'm going to do on page number 500 and I'm going to do the one from the textbook, and then I'm going to do a different one from the end of chapter or end of the book problems. On page 535, and again, my methodology is slightly different than what it does in the textbook. If the textbook makes sense to you, go ahead and use it, that's fine. This is how we do this. I'm trying to follow. How can Hess's law be used to calculate the energy change for the reaction that produces sulfur trioxide? SO3 is what we're trying to make. Sulfur and oxygen are my components. Now, it needs to be balanced, and so I would put a 2 over here and a 3 over here to balance the oxygens, which means I need a 2 here for sulfur. Now here's why Hess's law is important. Evidently, when we do this reaction, it doesn't happen in one step. So I can't put these 2 things in a bomb calorimeter and measure the energy change. It's not doable, because this is a kind of reaction that takes place in phases or in steps. But somewhere along the way, somebody in the world of chemistry did 2 other reactions and were able to measure directly how much energy was released or absorbed during those 2. And I can manipulate those. I can change those around to add up to this one. So our goal is to answer this question. What is that number? Here's what I know. I know, number 1, sulfur. Now let's do this in blue. Sulfur plus oxygen produces SO2. Is it balanced? Yeah, that's good. And this has a delta H of negative 297 kilojoules. I know this. This is either given to me in the problem or I can look it up. Number 2, I know this other fact, that sulfur trioxide decomposes to sulfur dioxide and oxygen. If left by itself, it decomposes. And I can measure the amount of energy that happens when that happens. And that is 198 kilojoules. Now, we need to balance this as well, and it gives it to me on the problem here. Put a 2 here and a 2 here. So here's what I know. Here's what I'm trying to figure out. So your goal and my goal is how can I manipulate or change using only those three things that we looked at. I can flip them around. I can multiply them constants, but I need to get this plus this equal to this. Good? Fair enough? Whatever I do with these, I need to do these two numbers, and when it's all said and done, I'm going to add up my delta h's and get this answer. Now the way it stands right now is this plus this plus this equals this plus this plus this. So I look at what I'm trying to get to. Here's what I'm trying to get to. I need SO3 as a product. Is there SO3 here, here, or here? No. Do I have some SO3 on the left? Okay, it has to be here somewhere, otherwise I can't do the problem. Here's my SO3. It's on the wrong side of the arrow. So what do I need to do? Flip it, just like a one-way sign. Okay, flip it around. So we're going to rewrite this one as 2 SO2s plus O2 produces 2 SO3s. That's going to change my delta H from 198 to negative 198. Good. All I need to change is the sign because it's going from exo to endothermic to exothermic. Now, when I do that, when you work these problems, cross this out just so you don't accidentally use it later on, okay? Because this takes the place of this. So I now have SO3 on the right. Good. Do I have sulfur on the left? Yeah, right here. Do I have the right number of sulfurs? Okay, notice that my final reaction needs to have 2 sulfurs, and I only have 1. So what do I need to do? Multiply it by 2. Now, if I multiply sulfur by 2, and that's the only thing I do, I'm going to break all my stoichiometry, right? So I need to multiply everything by 2. So we take let's picture a giant bracket here or something like this. We're going to multiply everything by 2. And we're going to rewrite it down here. So 2 sulfurs, 2 O2s produces 2 SO2s. And what's my delta H going to be? 2 times 297, right? Good. 594. And it's still negative. Positive number times a negative is still negative. Negative 594 kJ. Cross this out so we don't use it, okay? I don't want to make a mistake because I got all these equations written on my board. So now let's double check. Are we ready to add these together? So do I have 2 sulfurs on the left? Check. Let's use some black here. Check. Do I have 3 O2s? What do you think 1 plus 2 is? Anybody? Yeah, just like in algebra. 1x plus 2x equals 3x, right? So 1 O2 plus 2 O2s equals 3 O2s. Good. Now what do I do with the rest of this? Ah, something cancels out. What cancels out? Yeah, look at, I got 2 SO2s and 2 SO2s. And again, just like in algebra, if I have 2x squared on the left and 2x squared on the right, right? Bye-bye. And so now this plus this equals this is exactly what that is. Yay. Okay, so we're going to rewrite the whole equation. 2 sulfurs plus 3 O2s produces 2 SO3s. And that means I can add these two numbers together. 594, 694, 794. Add 2 back. 792. And they're both negative. So negative plus negative is negative. Negative plus a negative is more negative. Okay? Guys, this is almost as bad an error as a lot of people. Just watch your negative signs, okay? Because when you're adding and subtracting negatives, it can cause some problems. So this is my final answer. Ta-da! Kilojoules, kJ. Got it? Makes sense? Okay? So there's only those 2 things. We can either flip them around or we can multiply. But our goal is to get these 2 things to add up to that. I did this in 2 steps. Right? flip that one around. We multiplied that one by 2, and then everything added up. Questions? Okay. Turn to page 900 and something or other. In fact, homework. Oh. What? I don't remember doing that. Page 987. 7. Page 987. Number 10. Let's do it. I got 3 reactions. Okay, number 10. Calculate the reaction. Calculate the delta H. Remember, you're on camera. We calculate the delta H for this one. So it's a synthesis reaction. Hydrochloric acid, ammonia, and our old friend NH4Cl, ammonium chloride. But I don't know the delta H. Oh, what? So instead, I've got 3 reactions that I do know the delta H for. And the first one is the synthesis of hydrochloric acid. H2 plus Cl2 produces HCl. And guess what? I need to balance this, put a 2 here, and we're done. The delta H for that one is negative 184. The second one is the synthesis of ammonia. N2, H2, and H3. And they usually give us these balanced already, but if you want some practice, you can. I need 2 nitrogens, and then I need 3 hydrogens. And so the delta H for this one is negative 92. And the third one, so I said, okay, there's ammonia, here's hydrochloric acid. How about that thing? How do I get that? Well, they actually give me a synthesis reaction to this one. So nitrogen plus chlorine plus hydrogen produces NH4Cl. And guess what? 1, 4, 2. I wrote this in the wrong order, so the 4 actually goes with this one. And the 2 goes with 1, 4, 2, and 2 over here. 2 nitrogens, 2 chlorines, 1, 4, 2. Yeah, there we go. Is that right? I think I copied it right. And this one is negative 628. Okay, so here's the problem. I know these 3 things. I need to figure out that one. So again, start with what you're looking for. I need to have, what do I need to have? I need to have this on the right. Is it? Yes. Check. I'm not going to worry about the quantity. Let's just get things in the right positions. I need ammonia on the left, and I need hydrochloric acid on the left. So I need to do both of these things, right? I need to do flipperoo thing on this one and on this one. I need to switch it around and change the sign. So we're going to rewrite this one, rewrite this one backwards. So I got 2HCl produces, and just the trick of the trade here, guys, if you line up your arrows, it's a little bit easier to see what's going to cancel out. I tend to like to keep my arrows kind of lined up here, so that's why there's a gap here. 2HCl decomposes to form 2H2 plus 2Cl2. And the second one, this is 2 ammonias decomposed to form nitrogen plus 3 hydrogens. I'll scroll this up here in a second. So I moved my scroll bar accidentally. I like it though. Okay, what else do we need to do? So that's going to get rid of this one. That's going to change that, by the way, to positive 184. And that's going to change this one to positive 92. Right with me so far. All we've done is flip 2 things around. So I got NH4Cl on the right-hand side. I got my ammonia and my chlorine on the left-hand side. And I got nitrogen, nitrogen. Those will cancel out. Chlorine, chlorine. Those will cancel out. Ooh, look at this. Like, boom, like, we're done almost, okay? So watch. So it's like, ooh, cool. So what cancels out? I got nitrogen, nitrogen. Yeah, I got chlorine, chlorine. Nice. I got 4 H2s and what? What's this? Ooh! 3x plus x. 4x, right? 4 hydrogens, 4 hydrogens. Now, here's the deal. Let's rewrite the whole thing. This says 2 HCl's plus 2 NH3s produces 2 NH4Cl's. And if I add these three things together, negative 628, positive 184, positive 92, we should get an answer, not the answer, an answer. 628, 184, 92, 352. And it's negative, because this is the big boy. It's negative 352 kilojoules. Now, is this the final answer?
No.
Why?
Divided all by 2.
Aha! So, this is what we're trying to find out for the coefficients of 1, 1, and 1. I have found an answer for the coefficients of 2, 2, and 2. Your choice, should you decide to take it. Is it to multiply everything by 1/2 or divide everything by 2? Which is the same.
Multiply by 1/2 here.
1/2 times 2 is
Yeah, but I'm
1.
just saying.
Okay, so whatever makes the most sense to you. If you think of multiplying 2 times 1/2 equals 1 or dividing 2 by 2, we're going to get HCl plus NH3 produces NH4Cl. And what's that thing to do with that number? Divided by 2. So half of 352 and 176 with the negative sign. Whoops, with the negative sign. Because the dividing by 2 doesn't change the sign. It's just negative 352 divided by 2, 176 kilojoules. That's my final answer. That goes with this reaction right here. Capiche? Let me turn this off.